has a density of rho 0, its density of oil. Plastic cup is a mass, sample of unknown mass. It's placed in the oil, the cup sample flow shown above. The oil overflows from pans collected, volume is measured. So there's going to be some volume of oil on the outside. Procedure is repeated with a variety of samples. On the dot below represents the cup sample system. Draw and label the forces that act on the system. Okay, well, if it's the cup sample system, then it's going to be FG and FB. Pretty sure that's it. And then derive an expression for the overflow volume. Volume more than overflows due to the floating system in terms of. So the overflow volume is just going to be a function of FB, right? That's going to be the buoyant force, because whatever you stick, when you put this in there, buoyant force is defined as what? What is the definition of buoyant force? Yeah, it's, in general, it is the weight of a displaced fluid. Buoyant force is the weight of the displaced fluid, and that's where we get rho Vg. So now we just have to solve that for V. Does that make sense? Okay. So it's key to know that definition there. Blah, blah, blah. Okay, so, yeah.
It's force and gravity.
I assume so, yeah, because they see the mass, the cup system, like both things together. Like the thing that made me believe that was the plastic cup of mass. Oh, here on this thing, the cup sample system was this. So it was like both of those added together. And then for part B, I don't really need to worry about that yet. I can just use this. I can use the definition of that. Then assume the data are obtained for the overflow, so blah, 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 bunch of stuff there. Graph the data on the axis below, plotting the overflow volume as a function of sample mass. Yeah, I mean, this is one of those, can you follow directions and gain 3 points? Or are you too stupid to be able to read? Yeah, that was kind of a weighted statement, sorry. I hope I didn't offend anyone. What's that? The answer for B, oh yeah, it just comes out to be, you take pass. It's like V is equal to FB over rho G. I mean, that's my, what's that? Oh, okay. I'll basically just use the buoyancy equation. Oh, okay, so, yeah. I'll use the buoyancy equation, and then I would set that equal to the weight of this. All right, yeah, so here you're just plotting the volumes, make sure you plot them accordingly. And then it says, this tells you, it says everything. Plot the volume, right, as a function of the mass. Like the things are already labeled, all right? Place numbers and units on both axes and draw a straight line. So you're going to do that stuff. And we've talked about this before, right? Do the best fit line. Don't include data points unless it matches your best fit line. And then when you graph it, when you go to find the slope of this, just pick 2 points where it's easy, like where it crosses, you know, like actual points on the graph. And then it's good if you get a, you know, wider just because I don't feel like filling everything in the graph. I'm going to take a look at this. Okay, we were right about that, so that's fine. 3, yeah, FB is this. Okay, so then, yeah, just using the definition of buoyant force here, and then solving for the volume. And then here, just graphing it out, best fit line, pretty straightforward. Okay, use the slope of the best fit line to calculate the density of the oil. So you're going to get some slope, and we've already created or wrote this. We did the thing where we said FV is equal to FG, and this was rho of the oil, volume of the oil times gravity, and this was mass of the cup plus mass of the stone times gravity. So that goes away, and then we know that the density is going to be mass of the cup plus mass of the stone over the volume of the oil. So then this is actually the opposite of our slope. Now, this is mass of the stone. Or no, mass of the sample. So these two combined should come up to the mass of the sample. So then all we have to do is say the density of the oil should equal 1 over slope. That's my thought. Let's see how that comes out. Is this actually mass of the stone or mass of the sample mass? The sample mass includes the cup, right? But did they tell us the mass of the cup? Okay, and this is sample mass. Okay, so if we take a look here, they're saying the volume. Okay, they're disaggregating the mass of the cup. Yeah, the sample's a little thing inside. Did they ever give us the cup's mass? Oh, like where's the y-intercept is? Because if the sample's 0, Alright, so alright, then how do you get that out then? So the way they did that is they're saying statement was that weight force is equal to gravity, and it was density of oil, volume of oil, gravity is equal to mass of the cup plus mass of the sample times gravity. So that went away. Plus mass of the sample. So then they did this, and they basically said the volume should be mass of the cup over the density, plus the mass of the sample over the density. That's going to give you the volume that it displaced. Yeah, so they got that same thing that we got there. And then yeah, you could do like probably so we could go back. We have this statement, and then if you find the intercept where it crosses the y-axis, and take that value, when you have no sample, you can get the mass of the cup. What's this? Oh, no, you don't know that. Oh wait, no, you know that the because the slope of that graph should be mass of the sample per volume. Slope is 1 over the density. so the density of the oh, these are just 2 points. Oh, that's fine. Yeah, the density is just, yeah, I think that's right. The slope of this is just volume, delta volume over delta mass, and that is 1 over the density. So that's fine. We're right. So the density of the oil is 1 over the slope. Right? That's the key that opens up together. And then what's the physical significance of the intercept? That's the key. Right? The significance of the intercept is that's the mass of the cup. Yeah, but the vertical axis is the y-axis. It's like this does something like that. And wherever this is, what that means is the mass of the sample was 0. And then from wherever the mass of the sample was 0, there, because like technically, if it was a sort of magical container that had no mass, okay, so, oh, okay. Displacement. So they just phrased it a little bit differently. Right? They're saying there's some sort of y value, there's some sort of oil, there's some sort of displacement of oil even with just the cup. And I think that makes sense to everyone, right? And then the displacement of the oil from the cup is going to be a function of the mass of the cup. But they just simply said this. If you said that so what is the physical significance of the intercept of your line? To me, the physical intercept would say I can calculate the mass of the cup by using the displacement. However you want to do it. They're trying to see if, what they're trying to see is, did you do this? Did you go from 0? Or did you like actually plot the points? You know, did you actually plot the points and see that it's this, and then it goes through that